This we have already done. Okay, it is on page 39, so I'm going to whip through it pretty quick. 2 to the power of x. How do I graph that thing? Well, if x is negative 3, that's 2 to the negative 3, which is 1 over 2 to the positive 3, which is 1/8, right? So if x is negative 3, this is an 8. 2 to the negative 2 is 1 over 2 to the 2, which is 1 over 4, otherwise known as a quarter, a half. Anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3 is 8. So, is 2 bigger than 1? Yeah, so it should be growing exponentially, right? What's my domain? All real. Goes that way forever, goes that way forever. What's my range? Everything bigger than, this looks like a what? Oh, it looks like one of those. Asymptote. So a y is greater than 0, where y is all real. Okay? So I don't expect you to memorize that. Just quickly plot the graph and boom, have a look. That's growth. Is a half less than 1? Again, this is on page 39, right? You already got this stuff. Yes, it is. So this isn't going to grow, it's going to decay. So 1/2 to the negative 3, I'll just do that one. I told you a little trick in grade 10. How do you make that thing positive quickly? What's a little trick? Flip this. And then this becomes positive. And that is 2 to the power of 3, which is 8. So if x is negative 3, this is 8. If x is negative 2, this is 4. And it's very similar to the same numbers up above there, only they're going in the opposite direction. Anything to the 0 power is 1. Okay, and if this is 1/2 to the 1 power is a half. 1/2 squared is a quarter, an eighth. And looks like it's decaying, correct? What's the domain here? Shall we? With us? What's the range? Everything greater than 0, because y equals 0 is an asymptote. Okay? Gets closer and closer and closer to the x-axis, but never touches it. Again, you have this already. Okay, we did it the first day. What's the relationship between that and that? Well, that one goes up, that one goes down. This is growth, this is decay. They're both to the power of x. But I think what we really care about is, do we notice something here? Those are pretty darn close, aren't they? Same. Okay? Same domain, range, asymptote. Okay. So top of 50, let's look at this guy. Graph y is 2 to the x. Well, we just did that. Okay, an eighth, a quarter, a half, 1, 2, 4, and 8. Okay, that's that. And could you put that in your calculator and check it? Yeah, you all can, if you got a graphing calculator. Any guesses as to what this is going to do? I'll live. Any guesses? I know it's going way back, like several weeks. But what does that do again? Moves this graph up or down. What does this do again? Right or left? Could it be? What do you think? Which way does this move this guy? 2 units. It's negative, so it goes in the positive direction. Remember, it does the opposite thing? Yeah. Let's quickly, what's a nice number for x here to plot? 2 would be nice, right? Because then that would be 0. So if x is 2, this thing is, anything to the 0 power is 1. Does that look like 2 units to the right? Is that this point 2 units that way? Yeah. What's another nice point? I don't know. Let's try, if x is 3, then I got 2. 1, 2, 3, 1, 2. Is that 2 units to the right? You think this also applies here with logs? I'm just going to shift this graph 2 units to the right. Yeah, it does. Every point here, I'm just going to shift 2 units to the right. It works. And plot them all if you don't believe me. What's the domain of the original graph? We just did this. How does it change if I slide it over 2 units to the right? Does the domain change? No. Still all real, because it goes forever and ever. Does the range change? Nope. Still the same asymptote. What do you think that's going to do? Well, let's have a look-see. I'll plot this guy first. An eighth, a quarter, a half, 1, 2, 4. That's 9, so that's 8. Domain. Range, same thing. Asymptote, same thing. Now, let's put in x0. So I'm going to have 2 to the 0, which is 1. If I add 1 to that, what happens? Up by 1. Yeah, everything's going to be up by 1 point. That's why it goes to 9 here. That's up by 1. That's up by 1. Now, how does the domain change? No, it doesn't. Still goes left and right. Does the range change? Mm-hmm. Yeah, because my asymptote changed, didn't it? Right? Now, my asymptote, colored on one, is here. Right? Keeps going closer and closer. That's an eighth. That's a quarter. Keeps getting closer and closer to that point. So my range does change. Because everything got shifted up by 1, including the asymptote. So if you're a memorizer, maybe you want to stick this in your head. I would just quickly plot it to see. Again, you can check that on your graphing calculator. When transforming, oh, this is not log. We're doing that tomorrow. This is exponential. So let's add that. Only the transformation here, 1 up, changes the location of the asymptote in the range. Okay, so just to emphasize, sliding it left or right, that's not going to change this. Okay, but graph it to see. Speaking of which, without graphing, what's the new range in the asymptote of that guy, do you think? What's the 4 going to do? Everything's up by 4. So my asymptote is not going to be y is 0, it's going to be y is 4. So that means it's everything above 4. Okay? But again, you know, quickly you could plot that to see. Is this going to change the range in the asymptote? No. But the plus 2 will. Oh, why did I write that? It's greater than 4. Okay? How about this thing? Well, 1/2, does that make a difference? I don't know, let's go see my graph. Ooh, I had the same asymptote, didn't I? So if I move it down by 4, what's going to happen? Y is not going to be 0 for an asymptote, it's going to be -4. So y has got to be greater than uh-oh. Is it going to freeze up? And no, I guess it's okay. Greater than -4. You know what? Let's put that in our calculator. Let's prove it. All right, graph it. Y is bracket 1/2 bracket to the power of bracket x minus 1 minus 4. It decays. Does that look like an asymptote of -4? Yuppers. Okay, count if you want, zoom it in, whatever. Put in the line -4 to see where it is. That's an asymptote. I know it looks like it's right on top of that line all the way to positive x infinity, but your calculator isn't that precise. You know it never ever touches it, even though it looks like it's right on top of it, right? Okay? Now, let's back up a bit. This is up or down. This is left or right. I don't remember what that 4 does. Is it a vertical or a horizontal? Is it on the y or the x? It's on the y, yeah, because I could divide that away, right? I could put that over there on the y. Is that an expansion or a compression? Good, you remembered. But I want to emphasize, because that's what I have down there, what does that thing do? Flips it. Reflection over what? X or y? Is it on the y or the x? It can go on the y. It's not on the x there, right? I could divide both sides by -1 and put over there. So that's a reflection over x-axis. So, guess what that's going to do? The exact same thing. That's a reflection over the x-axis. So this growth, instead of going like that and shifting it up 5 units, it's going to be a reflection. It's going to go like that and down 5 units. Okay, but I'll put that in my calculator in a sec just to check. Well, let's do it now. So negative, I got, well, let's put it in just like it is. 2 to the power of x minus 4 bracket, bracket, plus 5. So up 5, but it's reflected. Or, I taught you do reflections first, then move it up by 5. Okay? So that's actually not totally correct, is it? Okay, so reflections, then move it up 5. Okay, 1, 2, 3, 4, 5. That's where the asymptote is. So this is all the values, though not greater than, but less than 5. Okay? So same rules apply to logs. Inverse we've done before. Now we're doing it with logs. Or sorry, exponential functions. But one's the inverse of the other. So I got an exponential function. The inverse of that is a log. Okay, that's the definition. So in math terms, that's exponential. The inverse looks like that. Y. Remember how we get inverse? We swap x and y. So if I'm going to write this in log form, that's the base a. So I'm going to write log base a of y is, sorry, x is the exponent. That's the answer. So that's log base a of y is x. So if I swap x and y, is that? Okay, so that's the inverse. Because remember, algebraically, to get the inverse, we swap x and y. Graphically, it's a reflection over the y equals x line, which looks like that to you. Okay, so just look here and here. If that's a function, the inverse, y, I'm going to start it with y, log a, that's 3 here, that's the base of x. So y is log 5 of x. And same thing. So that, I'm putting it in this form, log form, to put that backwards. Okay, well, y, it still starts with y. The base is 4, that goes there, and there's my x. So y is 9 to the x. These are inverse. Okay, don't confuse that with just converting it to log form. It's converting it, then swapping x and y. So let's graph that for the, I don't know, 4th time. 1/8, 1/4, 1/2, 1, 2, 4. Oh, it's 8. Okay. Actually, I want to emphasize those points because graphically, how do you do the inverse? I said it, but someone else want to repeat it to me? Algebraically, I'll switch x and y. Yeah, that's how I can plot each point by point. But visually, this thing should look like what? A reflection over? Yeah. So some people are pretty good at that. They can just take that point and go bang, 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 bang and swap them. But let's be careful. This point is 0, 1. So I'm going to go 1, 0. This point is 1, 2, so I'm going to go 2, 1. 2, 4, 4, 2. 3, 8, I'm going to go 8, 3. Does it look right? Okay. -1, 1/2, I'm going to go 1/2, -1. And the other ones, well, you know, They get closer and closer to that line and never cross. That line is now down here. That's the asymptote. And then take your head, put it right on that dashed line. Does the left side look like the right side? If it doesn't, you did something wrong. That's a mirror reflection over the y equals x line. Okay, so again, of the original function, domain, all real, range greater than 0, that's the asymptote. That looks a little different for the inverse. Right? And if you remember, they kind of swapped places, didn't they? So my domain, but just look at the picture. X is everything greater than or equal to, no, sorry, not equal, everything greater than 0, which is what the range was before. Okay, I don't expect you to memorize this. It's just a little pattern some people try to take note of. So now, what about my range? Well, x was all real for this exponential function. For the inverse log function, now it's y. That's all real, okay? Because it goes up forever and ever and ever and goes down forever and ever and ever. Asymptote. What's the asymptote? X is 0. We'll never touch that line. Okay? And this guy, that was the same as this, only the other way around. So -3 was 8, -2 was 4, -1 was 2. Anything to the 0 power is 1. 1 is a half, a quarter, an eighth, so on and so on. It's closer and closer, never touches. Domain, range, asymptote. Take the inverse of that, plot the points. Fireball. Okay, so that's 0, 1. I'm going to go 1, 0. That's -1 and 2. I'm going to go 2 and -1. -3 and 4. Whoops, sorry. -2 and 4. I'm going to go 4, -2. 1, 2, 3, 4, -2. 1 and a half. I'm going to go a half and 1. 2 and a quarter. I'm going to go a quarter and 2. Do we see where this thing's going? That's my asymptote. Well, I guess I better do that one. -3, 8. I'm going to go 8, -3. Look good? Domain, range, asymptote, which is the same as that one, if you're scoring at home. Can you graph that? Those of you that don't have a base in your calculator, can you graph that? Yeah, that's log x over log 1/2. It's worth putting in. So, do I need a bracket? I don't think so. Log x divided by log of 0.5 should look like that purple shape. Right? Okay. It's not totally clear that this is an asymptote, but that definitely looks like that. You can still do that, and I'm saying that because, you know, I know some of you guys do have a log base option on your calculator. You can put in log base 3, log base 2. Okay, I do know that. So when I write your test, I'll keep that in mind. Okay? Lastly, the fun stuff. The special calculators aren't going to help you here. How do you find the inverse algebraically? You swap x and y, and then you solve it for y. And when I recall doing this before, some of your tests, some of you guys just did that, and I think you expected marks. Okay? Sorry, this is math 12. Okay, it's not that easy. I got to solve that thing for y. But now you guys have the skills, hopefully. All right? So that's swapped. I swapped my x and my y. How do I solve that thing for y? Well, that's an exponent. And I can use power rule to bring that thing down. But first, I want to make it prettier. I want to get rid of that 4. So minus it, or throw it to the other side. Change the sign. Take the log of both sides. Bring this down, because it's an exponent. Now at this point, there's a couple things you could do. First, I'll just keep it as a log base 10. Okay? And this, algebraically, I can split up. I can do that. Okay? This, I just want to keep it like that, because I want to solve this for y. I don't care about splitting that up. I'll just leave it like that. Okay? I'm not solving it for x. I'm solving it for y. So how do I get rid of minus log 2? Add it to both sides. Just like I did with this 4, by minusing it to both sides. So, log x minus 4 and log 2 is y log 2. Last thing, to get y by itself, how do I get rid of log 2? Divide it away. Whatever you do to one side, do to the other side, the whole other side. Okay, and that is y. It's by itself. I'll just write it this way because we're used to seeing it like that. The only problem is your answer won't look like that. You know what they're going to do? How could I make that prettier? No, you cannot cancel those because there's a plus sign here. You have to cancel it everywhere, right? But I could take log base 2 of everything. So that would be, this is the same as this. Log base 2 of x minus 4 plus, what's log base 2 of 2? All over, what's log base 2 of 2? Still 1. Do I need to put over 1? No. So your answer will look like this. Okay? You're algebraically, you're solving that for y, right? So I wouldn't call that simplify, you're solving that for y. So last thing I want to point out is, you don't have to wait to get down there. What happens if I did that up here? If I took the log base 2 of both sides? I would have log base 2 of x minus 4 equals y minus 1. What's log base 2 of 2? Yeah. Which I wouldn't have to write. So all I have to do there is, and I got the same thing, don't I? So it looks like a little less work, doesn't it? Same thing. Okay? So that may be something you want to do. Alrighty? You do that. That's the answer. I did take log base 3. Whoop. Okay, so do that and check it, and then of course the assignment, but it's not that long, okay? That's it. I gots to go. Okay. You're going to the office? Can you talk to Galloway and ask him to come down?